So our lesson today is on solving compound inequalities. So compound just simply means you're going to be solving more than one inequality at a time. So just like in our English language, we have compound words, like two words you can put together to form a word, like policeman or fireman. Okay, you also have compound inequalities. So that now notice these words are going to be very important. You see the word and you see the word or. Okay, that's going to be very important when we're actually graphing these. So pay attention to those words. So let's start off with example 1. So first it says translate the verbal phrase into an inequality and then graph it on the number line. All real numbers that are greater than or equal to -1 and less than 1 would look like this. Okay, so if everybody would write this down, all real numbers that are greater than or equal to -1, that looks like that, and less than 2 will look like this. Okay. Now we can also write that a little differently. So I want you to pay attention to this. So if you have two numbers like this, -1 and 2, and we're saying all the numbers between -1 and 2, but not including the 2, so that's why you see an open circle on that. You do want to include the -1, that's why you see a closed dot on that. Another way you could write this is write your smaller number first. Okay, the smaller number first would be -1 is less than or equal to x, which is less than 2. And this is what it would look like in set builder notation. Okay, so I want you to write that down. So notice I start with the least to the greater. And then notice now this greater than symbol changes to less than equal because I wrote the variable second, okay, after the inequality symbol, which means you reverse this. But just keep in mind when it's written this way, like a compound inequality, that means you're combining the two together. You simply start with your least number to your greater number, and then these will always be less than symbols when you do that. So whenever you write it from least to greatest, you always use your less, equal, and less than symbols. Okay. You wouldn't use greater than symbols for when you're writing it from least to greatest. All right, let's take a look at number 2. Now in number 2, okay, let's just see what happened here. Hold on. All right. So in number 2, notice this one is written slightly differently because now it says to solve it. So this has not been solved for y. Notice y has a -8 with it. So you're really solving two inequalities at one time. So if we were to do this individually, this would be one inequality here. Okay, that would be like one problem. And then this part, using the middle as the common part, would be like your second inequality. Okay, but we're combining them together and we're going to solve it all at one time. So instead of separating it into two parts like the yellow and the red, we're going to solve it as one problem. So when we do that, we have to isolate the variable. So we still have to isolate this variable. We got to get rid of that -8 that's in the middle. So what is the opposite of -8? +8. So it's just that now you'll have to do +8 here and +8 on the left and the right sides, because you're doing it all at one time. So you're not like taking, you know, the -5 is greater or equal to y -8 and solving that, and the y -8 is greater than or equal to -7 and solving that individually. You're solving it all at one time. So we're going to put +8 in all three sections. So this will give me 3. It's greater than, I'm sorry, yes, it's greater than or equal to y, which is greater than or equal to 1. Okay. Now remember I said in set builder notation we really want it written from least to greatest. So we really want the 1 written first to the 3. So if I do that, I also flip the inequality symbols. So when I write this one first, 1, I'm going to say is less than or equal to y, which is less than or equal to 3. And then I just put the bar, put the y again, and then I have it in set builder notation. So for set builder, you do want to have the numbers going from least to greatest, or greater in this case. We only have 2. And then your variable in the middle, which means these sides will always be less than or less equal sides. Okay? So this is saying that I want to graph the numbers between 1 and 3, and they will both have closed dots. So you can just kind of indicate where 0 is, and then put 1 and 3, and then we will put a closed dot on 1, closed dot on 3, and we basically just shade it in between. Okay, so the solution is between 1 and 3. So take a look and see if you have any questions on how I, solve both at the same time, both inequalities, because it's a compound inequality. Okay. All right, so let's take a look at this one. So this is a translating again. All real numbers that are less than or equal to -4. And now we're actually turning the table a little bit, and now you see the word or. Okay? Or greater than and equal to -1. Now for or statements, okay, this is how it translates. X is less than -4, or X is greater than -1. Now notice that these are not joined together, okay, like the and statement was joined together. So these are going in opposite directions. Okay, the circles obviously are not filled in because there's no equal sign. So X is less than 4 would be an open circle on -4, that is. And then shade it to the left, and X is greater than -1 will be open and shaded to the right. Now for set builder for an or statement, you will see the word or for an or statement, and that's the difference. You will actually see the word or. So you just simply write X, and it doesn't really even matter which one you write first, since it's an or. So you actually have to write out the word or for or. Okay, so whenever it's an or, you'll always see the word or. And you may not necessarily see that, and I'll show you what I mean in a few minutes. Okay. All right, so now that's for translating or. Let's actually do a problem involving or. So or statements you cannot do like an and statement where we actually solve both of them at the same time. So you really do solve them independently. So it's just like having two separate problems. So I'm going to give you guys a chance to solve both of these individually, and then we'll see if you have the right answer. So go ahead and work on that. All right, so let's just take a look to see what the answer is for the first one. Okay, you should have h is less than or equal to -2. How do we do on that? And then on this side, you should have h is greater than 6. So all you're doing is just solving these individually. Subtract 1 from both sides. That gives you -6. Divide by 3. -6 divided by 3 is -2. Okay, over here, add 5 to both sides. That gives you 12. Divide by 2, you get 6. So here it says h is greater than 6. So there's your open circle. Greater is pointing to the right. Here, h is less than or equal to -2. Close dot, shade it to the left. Okay. So since it is an or statement, to put in a set builder, you have your two answers right here. Just put the word or in between them. Put the bar for a set builder, put your H, and then there's your final answer. Okay, So you really just put the word or between the two answers. Put your such that symbol, that's the bar, and then put H again, and then put your set brackets. Okay. All right, so that ends the foldable. So what I would like for you to do now is go to page 10 in your packet. That's not it. All right, so we're going to go to page 10 that says actually compound inequalities. Okay, I'm going to do another and statement. Now, you might say, well, how do you know when there's an and when there's an or? You will always see the word or. So like starting with question number 5, see how you actually see the word or. And statements, you will not see the word or in it, and you may not see the word and, just like questions 1 through 4. Okay, so in your textbook, they might use and, they may not use and, so I want you to be aware of that. But you will always see the word or. So whenever you don't see the word, then you automatically know it's an and statement. Okay, because or will always be visible. So that's one way you can tell. All right, so let's just do the first one together. Okay, so I'm going to just rewrite it under the problem here. All right, so I'm going to subtract 6 from all sides. So that's going to give me, what is a negative 6 and a negative 43? Okay, a negative 49. And this gives us 21. Okay, so now I need to isolate the variable that's in the middle. So what's with the variable in the middle? What's the coefficient? Negative 7. So I'm going to divide everything by negative 7. Now, when you divide by a negative, what happens? You have to reverse the symbol. So a negative 49 divided by a negative 7 gives us what? Positive 7. Now I'm going to reverse the symbol. Reverse the symbol again. And 21 divided by negative 7 is negative 3. Okay. Now, recall I said for set builder notation, you need to have your numbers in order from least to greatest. So that means I have to flip again. Okay, because when I go from least to greatest, all my symbols should be less than symbols. So I'm going to write the negative 3 first. It's less than or equal to m, which is less than or equal to 7. And of course, if you feel like there's not enough space up here, by all means, you can use your spiral notebooks. That's fine. So now you're graphing between negative 3 and positive 7. So negative 3 should have a closed dot on it. Positive 7 should have a closed dot. And then you just shade it between the two numbers. Okay. Any questions on that? All right, so when you do an or statement, just go back to your foldable again. You are going to be solving those like individually, so they're just like two separate problems. You don't need to combine them together like we do the and. You just leave them individually. And normally when you graph them, not all the time, so I can't say 100% of the time, but most of the time those graphs will be going in opposite directions.